Hello dear student, today we are going to learn to resolve the network or to find out the value of a current from particular element by using the Thevenin theorem. So consider one network is a given. See, it is a network and suppose you have to find out the current I फ्लोइंग थ्रू दी 6 ओम रेजिस्टेंस 6 ओम रेजिस्टेंस में से पास होता करंट आई की वैल्यू हमें फाइंड आउट करनी है. तो बाय यूजिंग द थेवेनिन थियरम हाउ कैन वी फाइंड आउट द वैल्यू ऑफ द करंट आई passing through the 6 ohm resistance. So first of all we have to disconnect the 6 ohm resistance from the given network. So our circuit will be like this. Okay, 6 ohm resistance which is disconnected from the given network, and this terminal is labeled as the open circuit terminal A and B. Now find out the VTH. VTH means the Thevenin equivalent voltage source, and Thevenin equivalent voltage source means what? Okay, voltage across the terminal A and B. So it is voltage across the 4 ohm resistance. So how to find out the VTH? So to find out the VTH you have to first find out the value of a current I in this loop. So I is equal to 12 upon 1 plus 4 plus 3, which is a resistance. See, 1 ohm, 4 ohm and 3 ohm. All the three resistance are connected in a series, and V, that is the supply. So current I is equal to V by R. So V is equal to 12 volt, and R, that is the all the three resistance are connected in a series. So 1 plus 4 plus C. So 12 upon 8. So value of the current I, that will be 1.5 ampere. Now after the find out the value of a current I, we can find the voltage across the 4 ohm resistance. Now voltage across the 4 ohm resistance, that will be the Thevenin equivalent voltage VTH, and VTH is equal to I into R. Substitute the value of a I, that is the 1.5 ampere, and R, that is the 4 ohm. So 4 ohm. So our voltage VTH, that will be the 6 volt positive, that is the Thevenin equivalent voltage. Now second step is to find out the equivalent resistance, Thevenin equivalent resistance. तो थेवेनिन इक्विवेलेंट रेजिस्टेंस फाइंड आउट करने के लिए क्या होता है सेकंड स्टेप में कि यू हैव टू शॉर्ट सर्किट दी वोल्टेज सोर्स, or if any internal resistance is given, then short by that internal resistance. Here voltage source resistance, internal resistance, that is the 0. So from this circuit our circuit will be like this. Now here a voltage source is a short circuited and the value of a resistance is as it is. Now RTH is equal to what? So RTH, that is the Thevenin equivalent resistance. How to find out the RTH? To resolve this network by using series parallel connection. See, 1 ohm which is in series with the 3 ohm, 3 plus 1, that is the 4 ohm, and that 4 ohm is connected parallel to the 4 ohm, and that parallel connection which is in series with the 2 ohm. So our equivalent resistance will be 1 plus 3, which is a series connection and which is in parallel to the 4 ohm, and that in series with the 2 ohm. So 4 is parallel to 4. So 4 multiplied by 4 divided by 4 plus 4 plus 2. So finally you will get the 4 ohm. That is the Thevenin equivalent resistance. Now after finding the VTH and RTH, make the Thevenin equivalent circuit VTH which is in series with the RTH, and now again reconnect the disconnected resistance which is the 6 ohm. 6 ohm रेजिस्टेंस है उसको वापस ओपन सर्किट टर्मिनल के अक्रॉस में कनेक्ट कर दो, और VTH जो थेवेनिन इक्विवेलेंट वोल्टेज सोर्स है वो सीरीज़ में थेवेनिन इक्विवेलेंट रेजिस्टेंस के सीरीज़ में कनेक्ट करना है. और नाउ फाइंड आउट द वैल्यू ऑफ ए करंट I. So I will be VTH upon here RTH, equivalent resistance that is in series with the 6 ohm. So RTH plus 6, so 4 plus 6 and voltage that is the 6. So 6 divided by 10 you will get a 0.6 ampere. So this way you can find out the value of a current passing through the 6 ohm resistance by using the Thevenin theorem. So first step is to disconnect the 6 ohm resistance from the given network. Now the second step is to find out the VTH, that is the open circuit Thevenin equivalent voltage. Third step is to short circuit or set the voltage source to 0 if internal resistance is a 0, or if internal resistance is given, then put the value of a internal resistance here. Here a internal resistance is a 0, so set the voltage source to 0 and directly short circuit it and find out the value of a RTH, that is the Thevenin equivalent resistance. Then make the Thevenin equivalent circuit by connecting Thevenin equivalent voltage source in series with the Thevenin equivalent resistance, and then connect the again your disconnected resistance and solve for the your network and find out the value of a current I by using the Ohm's law V by R. So you can easily find out the value of a current for the particular element of the interest by using the Thevenin theorem.